In this demonstration, for the purpose of remote monitoring and control applications, for Industry 4.0 and Industrial IoT, Embedos will showcase its smart devices and real-time dashboard monitoring solutions. The Edge device can be connected to the Internet through wired and wireless Ethernet, as well as wireless SIM card-based 2G and 4G connectivity. Field device hardware interface options include the following: RS-485, RS-232, RS-422, CAN bus, Ethernet. In this demonstration, the Embedos Edge device will be connected to the Internet via a wired Ethernet connection. The following field devices will be connected to the Edge device: proximity sensor, CAN bus encoder, laser sensor, digital switch, LEDs to showcase threshold setting. On client, the Embedos dashboard, MWeave, is a real-time dashboard, meant as a designer utility, to view and create multiple dashboards at the same time. The dashboard can be deployed in 3 scenarios: on Embedos cloud servers, on client cloud servers, at on-site client installation. Proximity sensor, sensing the position of an object without touching it, is the job of a proximity sensor. Here we have a proximity sensor, connected on an analog input of the Embedos Edge device. This proximity sensor has an analog output of the range of 4 to 20 mA. Now we will demonstrate the real-time monitoring of this sensor on the Embedos MView dashboard. With the help of the screwdriver, we can see the change in proximity readings on gauge widget 3 and text card widget in the center of the dashboard, with a heading, Analog 3, Inductive Sensor. This particular proximity sensor is extremely sensitive, so the distance between the sensor and the screwdriver has to be kept small. You can see the real-time changing of the gauge and the line chart widgets of the dashboard. Encoder. We use the Edge controller's CAN bus field protocol to accept the CAN-based encoder data and push it to the MView dashboard. After seeing where the encoder is connected to the Edge controller, we move the encoder dial. As you can see, real-time visualization through the MView. Digital switch. To demonstrate the digital input, we are using a digital switch. Any DI sensor like a pressure switch, temperature switch, or similar, can be used. The sensor has 2 lights, in green and orange on top of it. When the laser makes contact, in a preset range, the orange light is turned on, which can be seen in real time, on the dashboard, digital 3 optical switch. You can see the immediate response on the dashboard, MWeave. Here we have tried the sensor multiple times to watch its instant response on the dashboard. Using Ethernet for internet connectivity, the Edge controller is transmitting digital switch data to the MView dashboard in real time. To demonstrate the analog input, we are using a laser sensor. You can see the sensor being connected to its respective analog input port on the Edge controller. An instantaneous reaction of the laser sensor can be seen on the dashboard. LED with end-to-end display. Here, we will give you an end-to-end display of control of an LED through the Embedos M-View. We also showcase how easy it is to program the edge controller using multiple interfaces. In this instance, we use the Node-RED interface, which is FlowLogic, a functional block programming platform. Primarily, the Node-RED environment consists of individual programmable blocks, which when wired together, can form one complex application program. Node-RED provides a browser-based editor that makes it easy to wire together flows, using the wide range of nodes in the palette, that can be deployed to its runtime in a single click. In this custom Node-RED environment of Embedos, the edge controller will use MQTT to accept data from dashboard and make the LED glow. Introducing the MQTT node to the interface, we will first add the topic, QoS, and return properties of MQTT. Once set, we will move to the actual function of MQTT. As you can see, we are wiring together the threshold function node with the MQTT node, and subsequently deploying the program on the edge controller. For the dashboard to receive data from the controller, we will set up an MQTT-enabled data source. We set up the name of the data source, name of the server, port number, client ID. And if the data source wants to use SSL and JSON message formats for its data packets. After clicking Save, we have successfully added a data source to the dashboard. For a widget to reflect the data from the source, we will set up the indicator widget with the newly set up MQTT data source. We choose Analog Alarm, MQTT data source, and choose its value properties, and click Save. To demonstrate the controlling feature of M-View, we have set up two LEDs at channel 1 and channel 5, that is two digital output terminals of the edge controller. We hope to turn these LEDs on and off remotely through the dashboard. Using the MQTT Writer widget of M-View, at the top right corner, we have set up the Embedos controller such that if we send on as text to the controller, the LED glows. Once we change the channel name to channel 1, we can see the second LED glow on and off in the same manner as instructed from the dashboard. If we send off to channel 1, the LED switches off instantaneously. At the start, we can see the LED being switched on and immediately going off. This is because the channel 5 is connected to the threshold setting of the laser sensor, connected to an analog input channel of the edge controller. If the laser sensor has a reading of more than 165, the LED is programmed to go off. This means that one data source can be showcased, viewed, and visualized in multiple widget forms, as an indicator, or a chart, or just some random text. To get more information about Embedos products and solutions, visit our website, or write to us. To get a quick consultation on industrial IoT, kindly give us a call at 836-924